Polynomials Addition. When adding polynomials, you are just simplifying. So you remove the parentheses and combine like terms. This can be done using a method that can be horizontal or vertical. So I'm going to show you an example of horizontal and vertical, and I typically tend to go with vertical. I used to go horizontal, but the longer I've taught, the more students I've had that like the vertical, and so I have kind of transitioned over and started using the vertical more often. But either way is fine. One's not better than the other. It's just whichever way you prefer, unless your teacher, professor, instructor tells you to do a certain method, and then you should do what they tell you because they're your teacher. So here, 7y minus 6, that's one polynomial, a binomial, plus negative 12y plus 9, a second binomial or polynomial there. So you'll hear me reference this, are they built the same? And when I say built the same, I mean here's a y term and a y term, and then here's a number and a number. So those are built the same. That's what I mean when I say built the same. So if there's a y squared, then there's a corresponding y squared in the other one. But if there's a y squared in one and not a y squared in the other, they're not built the same. So when you hear me say built the same, then that's what I am referring to. So these are built the same. So then vertical really lends itself to that whenever it's built the same. So first thing I'm going to do is remove parentheses. Since there's nothing out front but a plus sign on either one of these or nothing, then it doesn't change any signs. We have 7y minus 6 minus 12y plus 9. I see this plus here, but that means don't change the sign. This 12y comes down, plus 9 comes down. So some people try to get confused and say plus 12y or plus a negative. We don't want two signs there. We want one sign, only one sign. So I'm going to first, this is going to be horizontal. I'm just going to abbreviate that with an H on the next one, okay? But I'll write it out here. Horizontal. So this is horizontally written. Then I'm going to do the thing I did earlier where I underline the y's once and circle the numbers and combine them because those are like terms. So that's not necessarily part of everyone's horizontal method. It's just something that I do because if I can reduce my chances of a careless mistake, I've just made my life better in math because we all make a lot of careless mistakes, not just in math but in other things. But if we can try to reduce them, then our grades can come better, right? So hopefully your grade can become better because you are reducing your careless mistakes. So 7y minus 12y, they're different signs. You subtract. That's going to be 5y, and 12 is larger, so it is negative 5y. And then negative 6 plus 9, again, the signs are different. 9 minus 6 is 3. This time 9 is larger, which is positive, so that's plus 3. So negative 5y plus 3. And then let's come over here and let's look at a vertical technique, okay? So I'm going to take the first one, 7y minus 6. I'm going to write the other one underneath it, negative 12y plus 9. Now, typically speaking, on the just topping up here, if the first thing is positive, I'm not going to write anything right here, okay? But down here, if this first thing is positive, I might write a plus sign there. In this case, it's not, it's negative, but that's because typically when we do the addition vertically like this, we have a sign there, right? We're saying 3 plus 4, 7. So I'm going back to that vertical. So typically if that first one's a positive, I may put a plus there to remind myself, hey, it's plus, you're adding this. 7y minus 12y, well, again, you subtract and take the sign of the larger, so that's negative 5y, and then here's negative 6 plus 9. Again, you subtract. They're different signs. 9 minus 6 is 3, and the larger number is positive, and you get negative 5y plus 3. And our two answers should correspond to each other, and they do. You don't have to do both methods. Not unless your teacher tells you to do both methods. In my class, you don't have to do both methods. Okay, I've taught out of books that tell you to use one method and then tell you to use another one. I've taught out of books that don't care. I've taught out of books that didn't even present them as two separate things. So it just depends on your preference here, unless your teacher or your book or the instructions, whatever you're using, tells you to do it a certain way, then it's up to you. So then here we have 14x squared plus 3x minus 6 plus 24x squared plus 4x minus 21. So we have a trinomial plus a trinomial. Are these two trinomials built the same? Yes. We have x squared, x, and a number. X squared, x, and a number. Okay? So we have two things that are built the same way. So I'm going to remove the parentheses. So I'm going to do horizontal first. I'm going to do H for horizontal, V for vertical. 14x squared plus 3x minus 6. Over here, this plus sign says don't change any of these signs. What kind of 24 is this? It's positive in here. So when I write plus 24x squared, It's because this is positive, not because of that sign right there. That sign just means don't change anything that follows it. All right? So plus 24x squared because that's positive right there. There's nothing there. And then plus 4x minus 21. And then I'm going to say, okay, let me underline my x squareds twice, my x's once, and circle my numbers. So underline that twice, underline that once, and circle that. And again, there's nothing magical about that. There's nothing mathematical even about that other than I'm just trying to prevent careless mistakes and saying, hey, these are like terms. So 14x squared and 24x squared give me 38x squared. They're both positive, so you add them and keep it positive. Then a plus 3x and a plus 4x. Again, they're both positive, so plus 7x. And then minus 6 and minus 21. They're both negative. So you still add them. 6 plus 21 is 27. And since they're both negative and you're adding or subtracting, combining like terms, you keep it negative. So 38x squared plus 7x minus 27. And that is the horizontal method. So now I'm going to go and use the vertical method. Okay? So 14x squared plus 3x minus 6. And then we have 24x squared plus 4x minus 21. And look, because this is adding, it says don't change any of these, right? So I didn't change any of those signs, but I'm going to do what I told you a while ago. I'm going to put a plus here because we're doing this vertical. We're adding those together, so I'm reminding myself, hey, this is positive. Okay? That way it looks exactly like we learned how to do it in kindergarten, first grade, before we went to school, whenever it was. So 14x squared plus 24x squared is going to be what? 38x squared. And remember, when you combine like terms, when I put x squareds and x squareds together, when I'm adding and subtracting, that's combining like terms, I get a like term, meaning I get an x squared term. So 38x squared, and then 3x and 4x, both positive, are plus 7x. Don't change that to x squared, to 7x. And then minus 6 and minus 21, add them together and keep it negative, negative 27. And our two answers are identical. They should be. All we did was change the methodology with which we found the answer. We didn't change the problem. So then we should get the same answer either way, and we did. So I am now going to only use vertical. However, if you want to use horizontal, you can, but I'm going to use vertical, right? So here, negative 5x squared plus x, and then plus 6x squared plus 5x, are these built the same? Yes, there's x squared and x, and then x squared and x. So I'm going to come down here, negative 5x squared plus x, and 6x squared plus 5x. And then I'll say, okay, this 6x squared is positive, so I'm going to put a plus there. So then when I combine these, the signs are different. What do? I subtract. 6 minus 5 is 1 x squared. And I say, wait a minute. I don't ever write 1 in front of something. If I see it, then there's 1 there. So then that's 1x squared. So x squared is all I need. I don't need the 1 there. Okay? If you're in my very basic algebra class, I don't count off for that. But by the time you get up into college algebra and beyond, then I start counting off for those unnecessary ones. You don't need those. All right? So, but know what your teacher requires and doesn't require. All right? So 1x squared is just x squared. If you see 1, there's 1 there. And then plus x and plus 5x. Well, that's plus. Again, if you see this one, there's 1 there. So 1x plus 5x is 6x. And don't change that to x squared there. That's just, you're combining x's. It stays x. When you combine like terms, it stays like term. Combine x's, get x. Nobody says $1 plus $5 is $6 squared. You've never said that in your life. What is $1 squared anyway? Who knows? It doesn't exist. So x squared plus 6x. That's your final answer for this one. So look at this one. Negative 8y squared minus 13y plus 5, and then plus 3y squared plus 13y plus 9. What do you think? Well, they're built the same, right? Y squared, y and a number, y squared, y and a number. So I'm going to do this. I'm still going to do vertical here because I just like vertical better, and my students seem to over the years as well. And then we have 3y squared, 13y, and you'll notice I do this sometimes too. I just write down the things and go, okay, this plus sign says don't change any of those signs. So the 3y squared is positive, the 13y is positive, and the 9 is positive. So none of those pluses change. So negative 8 plus 3, they're different signs. That's 5y squared, and the negative is bigger, right? The 8's bigger and it's negative, so negative 5y squared. Then negative 13y plus 13y, that cancels, doesn't it? When things go to 0, they cancel. That goes to 0. Don't think that it has to happen, but it can happen, right? So don't think when it happens, oh, I made a mistake. No, it can happen. It may not happen often, or it may happen a lot. It depends on what problem you're working. All right, and then plus 5 plus 9 is plus 14. And I don't like the way this looks aesthetically, so I'm going to come down here and say, okay, negative 5y squared plus 14. And write it in together nice and neat there, negative 5y squared plus 14. So my middle term there, what we call the middle term, if it's in descending order, canceled. All right, it went to 0. All right, 4m cubed plus 3m plus 11 plus 5m squared plus 6m minus 34. Is this built the same? You might be tempted to say yes, but look at that first m in each one. One is to the third power and one is to the second power. So it is not built the same. So you have to be careful when you do vertical like I'm doing. If you do horizontal, you need to notate those differently. You know, like I put 2 lines under m squared, maybe I put 3 lines under m cubed. But once I go past 3 lines, if I go to the fourth power, I don't do 4 lines because I can't readily recognize 4 underlines versus 3. I might put a box around it or a star above it or put a check mark under it or something. But I'm going to do something different when I get to the fourth power or larger. So here, I'm going to say, okay, this is 4m to the third. But look, I notice over here I have an m squared, so I need to leave a column for m squared. I need to leave that column there. So here's what I'm going to do. No m squareds in this one, and then plus 3m plus 11. So what I've done is I've left this column here for m squareds. So when I get ready to write the one underneath it, I can write 5m squared plus 6m. These things get lined up, right? They're m's. And then minus 34. Again, those two things are constants. They get lined up as well. But there was nothing in the second one to put here, nothing in the first one to put here. But I needed a column for them, and we typically put things in descending order. And you need to know what your software requires, your teacher requires, because they may require you to put it in descending order. And sometimes that's in the directions. So, but if it's not, then it should be up to you whether you do that or not. It's just typically accepted in the algebra world to put things in descending order. So here I have these things lined up, and I'm going to go ahead and say, remind myself that's a plus. So here when I add these together, what is in this column with it? Nothing. And also here, nothing. So you just literally bring those two things down. 4m to the third plus 5m squared. And then plus 3m and plus 6m, they're both positive. You add them together. That's plus 9m, right? You add like terms, you get a like term. Combine like terms, you get a like term. If I put m's together, I get m if I'm combining terms, which is adding or subtracting, which is what I'm doing here. And then plus 11 minus 34, you subtract them. 34 minus 11 is 23, and the larger number is negative, so that's minus 23, and there's your final answer. So if you wanted to test yourself, pause the video and you go write it out horizontally and work it. And make sure you get the same answer. Because you should. Doesn't matter if you do it horizontal or vertical, you should get the same answer either way. All right, I'm going to turn the page here, and I don't want you to have a heart attack. Okay? Because what happens, we get in math and we get in algebra and we see all these fractions and we just freak out. Just stay calm. Let's first look at what we have. We have adding, right? We need to recognize we have a parenthesis and we're adding another parenthesis. So we're adding polynomials. So we're not trying to multiply anything here. We're not trying to, distribute anything here. We're just got a plus sign. We're going to remove parentheses, combine like terms. Are these two things built the same? Well, we have x to the fifth. We have x to the third. We have x squared. And then we have something without any x's on it. So those things are identical in the way they are built. They are built the same. Now look, they may have fractions as coefficients, and that may freak you out and scare you. Just stay calm, breathe. It's going to be okay. So let's look at this and say, okay, what do we do here? Well, I'm going to say 3/7 x to the fifth. Now, let me caution you. I've cautioned you in other videos. Do not use a slanted fraction here. Notice none of my fractions are slanted. And if you extended the line on all of them, they would slice the x in half, right? So there's no ambiguity whatsoever what's in the top, the numerator, or the bottom of the fraction. If you did this, you might mean that actually what you just did was write that, and that's actually wrong. That's why we don't use slanted fractions. The only way to use a slanted fraction and be correct here is to do that, and nobody I know does that. All right? So don't use slanted fractions. Don't do it. Just don't do it, okay? Just don't do it. And if you're a teacher out there and you're watching this and you do it, shame on you. You shouldn't do that because you do know when it's okay and when it's not, most likely. But you're trying to teach students who are learning. So that's why I use horizontal fractions and make sure there's no doubt, no ambiguity, because then they learn it easier when the rules don't seem to change all the time. All right? So 3/7 x to the 5th plus 3/4 x cubed plus 7/8 x squared plus 2. And then we're going to come down here and say, okay, negative 6/7 x to the 5th plus 1/4 x to the 3rd minus 1/4 x squared minus 2. All right, so I'm going to take a different color and use each term here. I'm going to do this in orange, okay? So I'm a big fan of thought clouds. I like to use, my daughter calls them thought bubbles. I like to use thought clouds. I go off to the side and I work part of a problem that may not be the entire problem, but it may involve, in this case, it's just subtracting two fractions, but on some of these, it may be finding a common denominator, and that may be several steps. So I don't want to sit there and write this whole thing down with all these fractions a bunch of times trying to figure out one term. So I'm going to go off to the side. I'm going to take these terms here, and I'm going to do them over here in orange, okay? So in my little orange thought cloud, I'm going to say, okay, I need to do 3/7 minus 6/7. Isn't that how you combine like terms? You just worry about their coefficients, and then you know it's going to be what? I already know this term is going to be x to the 5th, unless it cancels, and if it's 0, it's still 0x to the 5th, but 0 times anything is 0. So if it cancels, it'll be gone, but otherwise there's going to be an x to the 5th there. So 3/7 minus 6/7. Well, guess what? I already have a common denominator of 7, which is glorious. So I can just do 3 minus 6/7, which is what? Negative 3/7. And typically speaking, when it is one term over one term, we write that negative out front. Typically speaking, and we make it even with the fraction line. It's not wrong to leave it negative 3 and then all over 7, but we typically go negative and then 3/7. And you could do this. Right? These two things are synonymous. They're the same thing. All right? So there's the first term. There's the first term. Now let's go to another color here. We'll go with purple, and we're going to do this in purple. All right? So I'm going to take these two terms here in a purple thought cloud. Let's do this purple thought cloud here. All right, we're going to have 3/4 plus 1/4. Is that right? Because again, we know if unless it cancels, it's going to be x to the 3rd. It's going to be a like term, and we just need to add the coefficients. Well, again, we already have a common denominator. See, y'all were freaking out. We already have two of these, and they're already common denominators. You don't even have to find it. So you leave the denominator of 4, and you get what? 3 plus 1, which is 4/4. But wait a minute. What is 4/4? It's 1. So this is really 1 plus 1. But wait a minute. Do we write plus 1? No, we don't write the 1. We know if we see 1, there's 1 there. So again, you need to get in the habit of that. All right? And so sometimes even my students in my most basic algebra class where I don't count off for this. Well, if you're not counting off, why? Because I have in the past given a multiple choice final exam or a multiple choice test. And it's not going to say 1x plus 5. It's going to say x plus 5. And if you don't know that 1x and x are the same thing, you're going to think the answer's not there. So this is why it's a good habit to get in when you have a 1, just not to write it. So x to the 3rd, it's just 1x to the 3rd. So now we're going to go over here. We're going to have this blue here. We're going to do these in blue, the x squareds. So again, we know we're going to have an x squared here unless it cancels. So I'm going to take these two terms here and do this blue. We're going to come over here in a thought cloud. Okay? And in my thought cloud, I'm going to have 7/8 minus 1/4. So now I need to find an LCD because these things are not the same. So how do you find the LCD? Well, you start with the largest denominator, which is 8. And you say, does 4 go into 8? And the answer is yes. So the LCD is 8. So what I come back and do is say, okay, I need to find an equivalent fraction. Well, that's already over 8. Minus 1/4. And I need to multiply that by something so that I can get this to be all over 8. So what do I multiply by 4 to get 8? 2. And whatever I put in the bottom, the denominator, I've got to put in the top, the numerator. So 2 over 2. So now I multiply this. Don't go crossing stuff out. Multiply that together. That's the whole reason you're doing this. 7/8 and then minus 2 over 8. Now you can do 7 minus 2 over 8, which is 5 over 8, right? So I know my coefficient is 5 over 8. And it's positive, so there must be a what there? A plus. If it was a negative 5 over 8, I'd have a minus there. Like the first term that was negative 3 over 7. And then the last one, look at the last one, y'all. They're just whole numbers. Plus 2, minus 2. What do you get there? That cancels, right? You don't put plus 0. Again, if you don't have it there, it's not there, right? So you don't put plus 0. But that's what it is, right? It's plus 0. We just don't write it. So that canceled. It doesn't have to cancel. It just did here. So that is your final answer right there. All right? Negative 3/7 x to the 5th plus x to the 3rd plus 5/8 x squared. That's it. And the only one I had to find a common denominator on was the x squared. And notice I broke it up. Orange thought cloud, purple thought cloud, blue thought cloud. I encourage you, when a problem looks overwhelming, break it up into parts and try to work on that part and figure that part out. I don't think any one of those parts was overwhelming. The blue thought cloud was the hardest one because we had to get a common denominator. All right? So I hope this helps in adding polynomials. All right? Adding polynomials.